Hello everyone. Am I audible?
Yes.
Okay, perfect. How are you, Dipal?
Superb,
What's going
superb.
on?
How about you?
I'm good. Also good.
Great.
Thanks for asking. Okay, just give me a minute, then we'll start the class, okay? Okay. Uh, so let's start the session. So in the previous class, we had a lot of discussion on CNN, right? We had a
Yes.
discussion on the layers.
Yes.
Then we have taken a PDF of notes of the CNN. Then we have taken uh, layers of the CNN, okay, the pooling layers and all these things. Now it's time to make the CNN model. Okay, the image classification model. I think that's exactly we are going to do in the next class, right?
Hmm.
So let's do one thing. Let's open a Google Colab and create a new file for CNN image classification. But before that, I'm going to introduce the dataset that we are going to use for this model, and that is CFAR 10 dataset. CFAR 10 dataset. Okay, see. So basically, CFAR 10 is a widely used dataset in the machine learning, particularly for computer vision. Okay, and image classification. So that's why we are taking this dataset for our CNN classification. CNN image classification. And if I talk about the data set, it consists of 60,000 images of 32 cross 32 pixel of color images. So remember these things. In ANN, we had taken a grayscale images, right? Uh, the MNS data set, in which we have a lot of handwritten digits images. But in this, we have a color images belonging to 10 distinct classes, 10 unique classes for aeroplane like automobile, bird, cat, deer, dog, frog, horse, ship, and truck. These are the categories that we have almost 50,000 images in training part, and 10,000 images in test part. Clear with the data set?
Yes.
Okay, so like these are the 10 different categories. So if we have 10 different categories, uh, so almost, if there is 50,000 data set, then we have 5,000 each category. And if we talk about images, see, you will be able to see this kind of images. See, so we are going to use this data set, and we will classify whether the given image is truck, whether the given image is horse or car, or any kind of uh, category which we have in this data set.
Just like CAPTCHA.
Not like a captcha. Yeah,
Okay.
but you can say these images are not highly definition images, not in HD.
Okay.
They are just like 32 cross 32, and
Okay.
this data set is basically developed for making a classification model for learning purpose. Okay.
Okay.
Because it will take a lot of time to download the data. Definitely, we would do this. Right after today means tomorrow, we will take a very clean and very high definition of images, and almost it takes 2 GB of data, or 1.8 nearly data, and we will
Mm-hmm.
download that. I will share with you a link so that you will download that data, and we will use Jupyter Notebook for making the classification model of these data. Okay,
Mm.
but today CFAR data is good for the model. So I hope you are aware with the data set.
Yes.
Okay. Okay, so let's make a name of this file, CNN image classification model. I will write here CFAR 10 dataset. And you can learn more on this, like purpose, the benchmark data set used to evaluate the performance of various machine learning algorithms, and 60,000 images, or each of 32 cross 32 pixel images labeled with one of the 10 classes. That is divided into 50 and 10,000, and allowing researchers to train and evaluate the model. So I will copy this for understand about the CFAR data set, and I will paste in this file. So first of all, what we are going to do, as usual, as always, we are loading the libraries. Loading the libraries. So import TensorFlow as AF from TensorFlow dot Keras import, because we are going to take the data set, we are going to load the data set from the Keras. So that's why import data sets and also layers and models also. And for visualization, import, tell me what the library for visualization.
Matplotlib
Yeah, exactly.
dot pyplot.
PyPlot, yeah. And import NumPy, because whatever the data we are using, that will automatically converts into a NumPy arrays. Why? Because we are taking images, and images are nothing but these are the matrix data. So it is already converted in NumPy array. So import NumPy as NP. Just run this. Now it's time to load the data set. Loading the data set. Do you guys remember what is the syntax for loading the data set from the Keras? Anyone from you? Saurabh, what about you?
Uh, mm,
See, uh, the data set is already splitted in training and testing. So that's why we will define the variable for the training and the testing part. So in the bracket, I will be using x underscore train
mm.
and y underscore train.
Okay.
Then for testing, so you guys just keep the revision of all these things because that is the main thing that is really helps to face your interview. Okay, so because the coding is very very important. Otherwise, when someone asks you the question,
Huh.
usually it happens not for you also, but for me also. You will be totally blank even if you know the answer.
Come again, I
Right.
didn't get you.
I mean, if someone asks you the question directly in
Huh.
front of you,
Huh.
and if you
Hmm.
know the answer, then after you will be totally
Hmm.
blank on that question. So it's just about the fumbleness. Okay.
Okay. Okay.
So just keep the revision of all these things. Okay, whatever the topics we
Right.
have
Right.
covered in the
The
past
revision.
classes
Yes, revision is essential.
is very, very important. Data sets from data sets because we have taken data sets here. With this, we will use CFAR 10 and just write the attribute load underscore data and put the parenthesis and just run this. See, it's downloading. Now check the shape of the data set. X underscore train dot shape. See, we have 50,000 images in this. But what you will say about this 32, comma 32, comma 3? We'll explain it.
So it's
Tell me
32
like,
pixels by 32
Mhm.
pixels and 3 channels for RGB.
Exactly. The three means three stands for three channels. Why? Because we have taken colored image, not the grayscale image. Okay. So by default, uh, whenever we are taking any color image, it will give you three channels. And if you check the shape, it will look like this, like the dimension, whatever the dimension of the image is. And the last one is three. Three stands for channels. Also check for the testing part, x underscore test dot save and y underscore train. So it's 10,000 cross 32 cross 32 cross 3. Okay. Just apply the shape here. And in y training, 50,000 cross 1. Now, that means containing 50,000 images, and each image has a dimension of 32 cross 32. With
So this 10,000s and 50,000s are the number of images in the database,
Yes.
right?
exactly
Okay.
10,000 for testing part and
Mhm.
50,000 for training part.
Hmm.
Channels. Now just do one thing. Take the first picture. Randomly take the first picture from the data set. Let's say from the training data set. Are you trying? I'm just waiting for you. How will you take the first picture from the data set?
Xtrain bracket 0 bracket.
Without using any function? X underscore train. Is that you want to say?
X train, Y train, then X underscore test, Y underscore test is equal to
No. I want the full picture. I want the full picture. I don't know
load
what.
data. Is that cifar10.load data?
No. I'm just talking about visualization of the data set. I want to visualize my first image. Okay. See, but before that, if I say X underscore trend, if I take the first image, I don't know what exactly this image is, but it's 32 cross 32 cross 3 image. But if I check the show data, so it will give you all the data, all the matrix of that particular data, that particular image. See, it's very simple. PLT dot, we have a function called IMShow. If you guys remember, IMShow. And in IMShow, I will provide X underscore train, and I want the first image. Okay. And PLT dot show. Because I already told you the dimension is a problem. Let's do one thing. The quality of the image is not very good. Okay, that's why the image is looking like this. See, in the box format. in the matrix. So for this, I will
But
do,
it is but obvious that it will be something like this way only. And because it is 32 pixels, right? 32
yes,
pixel by 32 pixels. So we need to look it
will
by
try to
going little bit far away or
yes,
increase the resolution.
yes, yes. No, we cannot increase the resolution, but we can make this image dimension short to analyze which picture is this. Okay, so let's say make it 15 cross 2. Let's open it. So this is the dimension. I think it's look like a frog. If you see, these two are legs and this is the head of the frog, right? These two legs, and this is the lower body and this is the cover, like this is the upper body, and these two are uh, these two, I think these are the eyes of the frog, right? Okay, we can take one more random picture. Let's copy this, Control C, Control V, and we are just taking fifth image, means sixth image.
Oh, it's a car.
Okay, it's a car, right? And now in the Y train, Y underscore train, and I am checking the same image, like fifth number of image, and it says 1. Okay, so in the probability distributed value, I can say at index 1 we have the car image. Okay, so like if we are predicting any image and if we are getting 1, that means it's a car. Okay, for the fifth image.
Sir, can you go a little up? I missed
Yeah, sure.
that one.
Is that
Okay. Oh, okay. Yeah, just have to run. No, it is not. Yeah, okay, thank you.
yeah?
I'm done, thank you.
Okay. Now tell me guys, what is the next step? We have checked our data set and we have taken the images, like we can take the random image, like fifth, sixth image, and you can take 10th of image, like, okay, and you can check randomly. Let's take one more. I want to check for 100th image. Again, this is a car. What is this?
Okay.
I think this is a plane. Okay, we have completed our testing the images. Now tell me, for building a model, what would be my next step? Saurabh?
Normalization of the data.
So you are asking or you are telling?
No, I think it should be normalization of the data.
Yes, 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 exactly. So be confident on your answer, okay?
Yeah.
Second process, the second step is your normalization of the data. Now we will normalize our data set. What is the maximum pixel value of these image?
So it's 255 in each channel.
Yes, exactly. And I can also check like x underscore train, and for the first image, I will apply max function. See, it's 255. Okay. So that's why maximum pixel value is 255. So x underscore train is equals to x underscore train divided by 255.0, and x underscore test is equals to x underscore test divided by 255.0. Let's run this. Check the reshaped data. Not the reshaped, normalized data. X underscore train, and for the first image, 0. This one. See, all the images, like all the data is normally transformed from 0 to 1, in between 0 to 1. So like 0.231375, and see, and if I check the maximum number now for the transform data, x underscore train, for the first image, I'm checking maximum value. See, 1.0 means your data is normalized between 0 to 1. Okay. And similarly, you can check for the minimum value, x underscore train, first image, and dot min. See, 0.0. Clear, everyone?
Yes.
Now, what would be the next step?
reshape the data to convert each channel into 1D.
See, no need to do this because CNN is very smart. It will automatically take the linear data set. Okay. So no need to reshape these values.
Okay.
Create a model.
Yeah. Now we are going to build a CNN model. Okay. Neural network. Now we build a CNN network, neural network. So CNN is your variable for the model, and we are taking models, and with models we are taking sequential model. So in sequential model we will apply the layers. Okay, like 2 to 3 layers we will apply on the sequential model. Sequential, and in this I will pass layers. So layers dot, because we are taking convolutional neural network, we are working on convolutional neural network, so we have a function called conv2D, convolution 2 dimension. CONV and 2D, conv2D, and in this layer we will apply some filters because we have a big data like 60,000 images we have. So let's take 32 filters, and these are the kernels. Okay, filter is the kernels, and kernel size should be 3 cross 3. Then comma, and in this we will take activation function also. So activation is equals to, we are taking a ReLU function, and we have to define the input shape, shape. So what is the input shape of our data set? 32 cross 32 cross 3. So this is your first layer. Okay, but I am also applying pooling layer. So in pooling layer we are applying max pooling layer to concise your image, to concise your feature output. Okay, feature map. Layers dot max pooling 2D, and the size of the max pooling 2D should be, just take 2 cross 2.
Sir, what's
Now
the
this is
function of pooling? What actually pooling does?
okay. So let's say we have a filter of 2 cross 2. Okay, and in our kernel we have some matrix value, and this is the sign of the convolutional operator, and this is your input image, input, and this is your filter or kernel. Okay, and right after the calculation means whatever we had seen in the last class, right? We have a n minus f plus 1. Okay, and right after this we got a number. So let's say we have number of 25, and then 20, and then 15, and 24, 10, 10, 5, 10, and 0. So what maxpool will do, maxpool will apply on this, and it will take a maximum number, okay, maximum value from this matrix. So what is the maximum value from this matrix? 25.
25.
So it will take 25. Then again, one more filter, this kernel will apply on the second type of input data, and it will take another, like whatever the maximum value. So like 30, then 40, then 50, then 60, or then 70. So what actually we are doing, we are taking the maximum important features. Okay, so maxpool will apply on this, and it will take the maximum important feature from our feature output. So it will give you concise and accurate image. So that is the main work of maxpool. So we have, let's say we have a dimension of 32 cross 32. So it will reduce by, it's an assumption. Okay, let's say it's a 32 cross 32, and it will reduce by 28 cross 28. Okay, so now this is your transformed image, and it has the maximum importance of the feature.
Okay. So is the same like dimensional reduction like we saw
You
earlier?
can say
Yes.
dimensional reduction, but it's not a dimension reduction, but it gives the exact feature of the image.
Okay.
Okay, when we have a large amount of data set, so it will take the important feature of that image, and it will uh, drop in a second image, like what is like whatever the feature output or feature map we have. Okay,
Mhm. Okay.
now let me do one thing. I will be writing about maxpool, so you will be easy to connect with this. See, maxpool is a downsampling technique used in CNN to reduce spatial dimension of the feature maps. Okay, copy this. I will paste here. Now, this is your first complete layer. First complete layer. Okay, now it's time to apply a second layer. So layers dot conv 2D. Now this time I'm using double number of filters. So for the first layer, I have taken 32, but now I am taking 64. Okay, for better accuracy. And let's take kernel size. Kernel size should be same. 3 cross 3. 3 cross 3. And again, activation is equals to ReLU. And for this, layers dot max pooling two D 2 cross 2. Now I have applied 2 layers. Now I want to apply a flatten layer. Okay, so flatten layer is your last second layer, and that is what it will convert all your data into linearity form. Okay, in the vector format. Layers dot flatten, and it will contain a fully connected layer that is called dense layer. So what I'm going to do is I will apply layers dot dense, and in dense we are taking 64 neurons, just same as the second number of layer. Okay, and activation for this layer should be ReLU, and for the this is for the first layer, and this is for the second layer. Layers dot dense. I'm taking 10 neurons, and activation is equals to just take softmax. Okay, so this is your final neural network for the CNN. We have applied 2 layers, and 2 layers for the uh, filter and kernel, and 2 layer for the fully connected, or we can say flattened layer. Just run this, and then after we will compile our model. Okay, whatever the neural network we have created, we have to compile in a matrix. So what I will do, CNN, I will write, let's compile the model. CNN dot compile, and in compilation we will use optimizer, we will use loss, we will use matrix also. Optimizer is equals to, just take Adam, and loss sparse categorical entropy, sorry, cross entropy. And matrix is equals to accuracy. Okay, so we have just compiled that model. Now we have to train the model. Now we will train the model. So we have a fit function, CNN dot fit, and in fit I will pass x underscore train, comma y underscore train, comma epochs is equals to. So what epochs will decide? Tell me, Deepal, what is epochs here?
Epoch is the timing, isn't it? I think, but over here, is it different? I am not sure about it. But so far, my knowledge, it is a particular date from where it is said to be at the beginning of the counter, clock counter.
Sindhu, what do you say about this? What is epochs here?
Iteration
Is
of
it
the
the num
train.
sorry. Yeah,
Or the
number of
one loop
iterations.
itself, one loop in the complete loop in the data set.
Number of
The
times
number
the
of times, yeah,
Yeah,
sorry, go
good.
ahead.
A number of time. A loop. Can we say it's a loop or the complete the time it gets to pass through all the data?
Yeah, who said number of times? What you say? Swarnima? Is it you?
Yeah, number of times training will take place.
Exactly. So if I pass 5, if I pass 3, if I pass 10, it will decide how many times I want to train my model. So every time when it train on the same model, it will increase the accuracy. Okay. Why? It is just like you are learning to you learning the bicycle. Okay. So for the first time, you will learn 50% of how to use the bicycle, and for the second time you will increase your learning part. Then for the third time you will nearly to champion on that. Okay, so it is just like a optimization. Okay, optimizing your model, so it will decide the number of times of epochs. And it is basically it is the concept of back propagation. Okay, let me show you. Brock, Backpropagation is a supervised learning algorithm used to train artificial neural network by iteratively adjusting the weights and the bias based on the errors between the network's predicted output and the actual target output. Okay. See, forward pass, then calculate loss, then backward propagation, then we have weight adjustment. See, input data is fed through the network. Forward pass means if you have taken if the model made the 20% or 25% of mistake, okay, so it will take the model, it will take the image to the backward layer, okay, then it will compute this, then again it will pass to the second layer, then it will again it will make the you know what we say, show you. See, let's say we have an image. Sorry for the writing. Let's say we have an image and this is your 100% complete image and we have 2 to 3 layers. Okay. And this is the first layer which extract the primitive feature. So while classification, this layer will pass the primitive feature to the second layer. Then again, it will extract some more advanced feature of the image, and then all these feature will pass to this layer. So by continuing this is the higher chances that we got some errors while we are extracting some features of the image. Okay, we get errors. So this backpropagation method is used to minimize these errors. So let's say if it is found that we got 20% of error, so it will pass 20% of the error to the backward layer. Then again it will compute the 20%. Then again it will pass the 20% 20% of error right after the computation or calculating. Then again it will pass to the next layer. Okay, so now this 20% error is now reduced by 10%. Then again it will pass to this layer. So like this is a mechanism of backpropagation. So we have forward pass, we have backward pass. Okay, so forward pass for next layer and backward pass for giving the
Correct.
errors to make it correct. Okay, are you guys getting this point?
Yes, yes, got it.
Nice.
Okay, so we are just talking about epochs. So let's say I want 10 epochs, same as the previous layer in AN, and we have taken 10 epochs. Okay, now simply just run this. So see, now it's working. It's calculating the accuracy. It started from 20% of the accuracy and it's increasing. It's increasing the training accuracy. Okay. See why it is taking a lot of time as compared to the ANN, because when you see we have MNS dataset and the part of training the model is very short as compared to this one. What is the reason?
We have more channels here.
Yeah, we have more layers, then we have a large amount of data set as compared to the MNS data set, because that was a grayscale images and these are the colored images. So obviously the size of the data set is increased, right? So that's why it is taking a lot of time. Now you can compare. If you are passing this data set like CFAR data set to the ANN model, it will take a lot of time as compared to this. Okay. The time will increase by almost 2x. It will take a double time to train the model when it passed to the ANN. So that is the beauty of CNN, because it works on the principle of max pooling. So it will extract the main feature of that image. So again, it will take a short time to train the model. Just wait for it. What about you guys? It's training or not?
Yes, it is.
Okay.
Yes, it is.
And I'm going to plan for a complete the 100 or 120 number of questions for the test, complete full length test. What do you say for this? Make the
When,
voting
sir?
on this.
When?
Next week.
Okay.
Next week on Sunday or Saturday?
On Saturday.
Is it possible to put it on Sunday?
Okay.
Yeah, thank you.
Okay, so next week, Sunday will be the test. Okay.
Okay.
Okay. And the topics?
Complete, including
Okay.
Python, including data science, including statistics, whatever you have learned in the past classes.
Okay. But in this module 6 also, that CNN, up to CNN, or
Yes, up to
recurrent neural network, RNN, LSTM, NLP
see
will
by
be
tomorrow we will take we are going to take for introduction of RNN, but not for the hands-on. Okay, so
okay.
it will it will not include that RNN part. Okay.
Okay. So till CNN, can I say?
Yeah, till CNN. Yes,
Okay, okay.
because tomorrow we are going to make a image classification model. Okay, a different type
Hmm.
of project.
And again, it will be same type of MCQ type?
Yes, yes, the MCQ type.
Okay, okay. Thank you.
See, we can move for GPU also. Okay, let's finish this, then we will discuss it. Now it's using CPU. We can go for GPU also. Okay. So instantly, it will increase the timing for training the model. Okay, it's 2x faster.
How do we know it's using CPU and not GPU? Or by default it uses CPU?
By default, it's CPU. Okay. If you
Okay.
want to increase it, then we have to change the runtime.
Okay.
So how many of you have completed the training part or is still taking the same timing?
For me, it's the same, almost.
Okay, okay.
Yeah, same for me as well.
Okay, it's done. All of you, what about you? Done, everyone?
Yes, mine is done.
Okay. See, if I want to change my runtime, see, we have a lot of option. Hardware accelerator. See, by default, it's CPU. Okay. And we can use T4 GPU. Okay. Which which will increase extremely high level of timing. Okay. It will take a very short time to train the model. Okay. So disconnect and delete runtime. So changing runtime attributes may terminate your current session. It will be like you can lose somewhere. You will lose the whole coding, okay, or the whole file. So that's why I'm not using this. But you can change for the next file or for the next image classification. Okay, everyone. Let me show you where you can change the runtime by just click here and change runtime, and we can move to T4. That is again totally free. Okay. Okay, everyone. Got this?
Yeah.
Okay, so just check the testing accuracy. Testing. See, our training accuracy is 78.91 somewhere, and we can check the testing accuracy also. Accuracy. So CNN dot evaluate X underscore test comma Y underscore test. Let's run this, and so it says 94.71. Okay, now it's time to make the prediction. So Y underscore Fred and CNN dot, we have a predict function, and X underscore test. Just run it. Okay. Now Y underscore Fred, and I'm just taking first image. So again, it will give you in the probability distributed values. Okay. So these are the probability distributed values. To convert it, we will use np dot argmax and use in the loop. So Y underscore Fred underscore label, just make the variable, and np dot argmax for I value, for I in Y underscore Fred. Let's run this. Now Y underscore Fred underscore label. And I want first 10 rows, first 10 output. Let's run this. So it says 3, 8, 8, 0, 4, 6, 1, 2, 3, 1. So this is the index position of that particular image. And we can check for actual output. Y underscore test. And I want 10 images, first 10 images. So 3, then 8, then 8. And the actual output is also 3, 8, 8, 0. Okay, 6, 6, 1. It says 4 and my model says 6. Okay, so somewhere this is because just because of we are getting 70, how much testing accuracy was 94. Okay, so 94.71% of accuracy we are getting.
So I have a quick question. So can you scroll up a little bit?
Yeah.
Yeah. So y pred 0 and we got an array there with probability distributions, right?
Yes, yes.
So since these are probability distributions, if we give the command sum y pred 0, then it should give us 1.0, right? Because the summation of all probabilities should be 1.
Yes, yes.
So I'm getting that summation equal to 1 here, but when I checked it last time with ANN, the summation was not equal to 1, it was greater than 1. So I don't know where was the mistake, but
What it was 1 point, it means greater than 1.
it was last time with ANN, it was greater than 1 actually. For me, it came out to be 2.7 something.
With YPRED
Yeah,
or
YPRED, yes. YPRED, yes.
okay. Mm,
I mean, it was it was also in the file you shared. I checked it later. So the summation of probabilities was not. It was greater than 1 actually, and it was not like it was a significant error. It was 2.7 something, so it was not like even close to 1.
okay, I understand. Okay, I will check that. Okay, I'm just noting this.
Okay, thanks.
Check that and we will discuss that tomorrow. Okay, so by applying argmax function, it find the index, or we can say the position of the largest value within an array. Okay, so this is just of your CNN image classification model. It is just not like a project, but tomorrow we will make a complete project which will provide you, when I run the program, it will randomly take the input and it will provide you whether this particular image belongs to cat or dog. Okay, it will be completely different from our two of the model that we have discussed the last week or for today. Okay,
Okay. So
see,
can
because it is yes.
so testing accuracy for you it's 94%, but it's different for me. It's 90.85%. Is it okay or
Sometimes
it should be the same?
it is okay. Okay, sometimes it is vary to your like data distribution. Okay.
Okay.
Don't worry about this.
Mhm.
So just try to make this model, the same model, once again from your side without seeing any code. Okay, just first of all, just watch the video or watch the see the complete CNN image classification notebook file from end to end. Okay, and just try to make the code from your side. Okay, it will really helps to boost up your confidence about writing the codes. Okay.
Okay.
And see, because this is in 2 dimension, you can make it in 1 dimension. Y underscore test is equals to y underscore test dot flatten. So basically, flatten will convert 2 dimension to 1 dimension. Y underscore test. So I'm just sharing this file in the chat box. So who have not completed, who are getting any error, just compare with this code. Okay, it's done. Okay, done everyone. And guys, for today, I have a very important work for today. I have some important work. So we will finish this class a little early, okay?
Okay, okay.
Yeah.
Is it fine for?
No, it's
Yeah,
okay.
yeah, completely okay. Yeah. Yeah.
Yes, yes. Then by tomorrow, we will meet in the same time, okay? And don't
Okay.
miss the class for tomorrow because tomorrow we will be creating a very complete end-to-end image classification model, okay? Which is totally different.
Okay, okay.
I won't be
Yeah.
available tomorrow.
Oh, Andrew got
So
some
come again, Andrew?
issue. Okay.
What do you say, Andrew?
No, I was saying I won't be available tomorrow. That's why.
Okay, you can watch the video, okay? If you are not available.
Okay.
Yeah. Okay then, guys. Bye-bye. See you
Okay, bye bye.
tomorrow.
Have a good day. Good night.
Bye.
Thank you.
Good night.
Thanks.
Yeah, bye. Thank you.